In the 16th century, Newton proposed that gravity was a universal force contained within the ether. In the beginning of the 20th century, Einstein proposed in his special theory of relativity that there was no ether at all, and that the effect of gravity was due to the curving of the geometry of the nothing, which was to be understood as a space-time continuum. If we are to present a short summary of the scientific activities of Einstein, it will be good to mention the following facts. 10 years before Einstein, Poincaré published his own version of the theory of relativity, accepting the existence of the ether. Einstein's explanation of gravity through his special theory was a mix of Galileo's concept of the relativity of speed. With Einstein, it was the relativity of time. Archimedes' theorem of the displacement of water by bodies in a fluid-liquid environment. Poincaré's theory. The electromagnetism formulas of Lorentz. Hermann Minkowski proposed the addition of time to a possible theory of the relativity of the space continuum as an integral part. Einstein developed his general theory of relativity of the space-time continuum with the aid of Marcel Grossmann, using the so-called Riemannian geometry. Alexander Friedmann changed the universe in the general theory of relativity from a static into a dynamic one that is expanding. Hubble proved with the aid of his telescope that the universe was expanding indeed. The Belgian priest Georges Lemaitre came to the realization that the universe must have begun its history from the explosion of the so-called primordial atom. That was how the theory of everything was born, beginning with the proverbial Big Bang. Until the mid-1930s, Einstein, like many other famous scientists, did not believe that much energy can be obtained from atomic fission. Einstein also created his famous formula about energy in 1905. In fact, 20 years earlier than him, Heinrich Schramm, Nikolai Umov, and Oliver Heaviside had already created another formula about the energy which included the ether as a carrying medium. With Einstein, however, there was no ether, and thus a character from the formula disappeared. Is this formula, however, correct? Most people accept it as a well-established law of nature, but it is only a hypothesis. In 2008, a team of French scientists using powerful computers found out that it was approximately true. It may be time for them to repeat their exercise, because we know today that there is no way that 100 kilograms of potatoes and 100 kilograms of plutonium or uranium could have the same energy potential in terms of nuclear fission. There is no doubt that the number of protons and neutrons in the nucleus of atoms, that is, their mass number, plays an immense role for the energy potential of any object. Most probably, the number pi also plays a role in the calculation of this potential, as far as the scientists have adopted the liquid droplet model of the nuclear fission. Today, as we live in the early 21st century, is it not more reasonable to suppose that gravity is in fact a force, but not a universal one, but a particular local one? That it is a specific polarity, figuratively speaking, a condensed bosonic field around the material, fermionic objects, and that the strength of this polarity is equal to the sum of the specific magnetic fields of all the atoms comprising an object. Or maybe it is most correct to suppose that the energy potential of a given object is in fact equivalent to its gravitational potential. Get yourselves acquainted with my postmodern theory of everything for free on my website, or purchase it in an electronic or a hard copy format from Amazon. It's time to open a new page in the science about the universe.